Good morning, everyone. This is Mohammad Nawaz. Today in lecture 4 of our UNIT3 SQL queries, constraints, and triggers, we'll discuss some topics like null values, comparison of null values, some logical connectives, complex integrated constraints. We are going to see this topic today. So in the last class, we have discussed about the nested queries, right? In which we were using some of the operators like in, any, all, right? So we are having some more operators like is null, is not null, which are going to deal with the null values. What do you mean by null values? The SQL term null, that is, it is used to represent a missing value. Means if you are giving a Google form to somebody to fill it for one project, you are writing a Google form and submitting to some of your friends and asking them to fill the details. If for any column, they don't know what that column describes, so they don't know what the value has to be put it there. So for that, what they'll do, simply they'll skip, or they can put some random zero number, or they can put some null as a null. So what do you mean by null? Null means a missing value. It represents a missing value. Suppose if I'm having a column, in that value can be applicable or not applicable. Means we are defining some domains based on the column. So we can't put a character value in the integer value, right? So we can't put a zero on that place. So we are supposed to write it as a null, so that later on, if we know what the value has to be put it there, we can replace that null value with some value which has to be put it there, right? So null values are going to be used for that purposes. So SQL provides a special column value, that is a null value, to use in such a situation where the column value is unknown or inapplicable. Like if I am defining some other domain and I am writing some other means, that is not applicable there, right? So for that purpose, it has defined a value called it as null. And it is very important to understand that a null value is different and a zero value is different. Null cannot be equal to zero. Null is not defined value. Means we can later on, we can define that value to some other value, but it is not equal to zero. Or if we are simply leaving blank also, we can't think that it is a null value, right? Space is different, zero value is different, and null value is different. This SQL, what they have done is they have defined null value so that the user can get an ease to fill the data in the table. If it's not known what the value has to be put, so simply he can put a null value, and later on he can update that value with some other value. So we'll try to see this null value with the help of some examples. Now, one more important thing: when a column in SQL table is optional, that is some optional tables also will be there, which is not defined for every person. Like I'm saying, okay, some employee table is there in which I am giving some commissions. So I can't provide a commissions for all employee now. So as in the table, I have to define some values has to be an optional. So in that case also, we can put this null value and we can save that data. So for example, we are having here student details, means for student name or for any person name, we can define as a composite attribute, right? Means we can define into further. So your name has been defined further as a first name, last name, and the middle name. So it is not compulsory that everyone will having a first name, last name, and middle name, right? Some can have a first name and last name, or some can have a first name and middle name, right? So here it's some examples, three records as given, who is having some first name, last name, and middle name. So the first person, Sunil Yadav, is having a full three first names, last name, as well as a middle name. Second person doesn't have, so we have simply put it the last name as a middle name as null, right? For the third person, we have taken the middle name as a null. So in this way, we can feed the data in the database. Means if we are not known what the value has to be put in the particular column or the particular instance value, we can simply put it as a null, so that if later on, if any update is required for the table, we can update it. Okay, so it's a better practice. Now, how to compare using the null values? Okay, so we have already seen some of the comparison operators, right? Like arithmetic operators, that is equal, greater than, less than, this or that operators, right? So we it is not possible always to check the null values with the help of this equal symbol or greater than symbol. We cannot give a query like select select asterisk from our student table where middle name is equal to null. I can't give. If I give that as a query equal to null, it doesn't give you the output, or it doesn't displays the records for that. So for comparison of null values, we are having two operators, that is null, is not null, is null, not null, I can say. Okay. So what is that is null and not null? It's a keyword that performs a Boolean comparison. Boolean comparison means what? When we are comparing, it is going to give a result as a true or false. Only two conditions is going to be provided. So with the help of is null, if we are comparing, what it returns true if all the value are null, and it will going to be represent false when all the values are not null, right? So is not null, it is also same as like of your is null. It is also performs a Boolean comparison, that is true or false. It returns true if the all supplied values are not null, and false if that is null values. So how to represent it? What is the syntax of is null? You can see on your screen is null syntax. So this is null and keywords of the null, that is null and not null, are going to use along with a where condition. So I can give the syntax. You can see here that select again the column names from the table name where condition, we are supposed to mention is null or is not null. Okay. How to disallow these null values, means how to overcome these null values. We have already seen the topic of constraints, right? What do you mean by constraints? With the help of the constraints, we are defining some set of rules over the columns of a table, right? Means we are defining what value can user put in the table with the help of a constraint. Whether he can put a null value or he can simply place an integer value, right? That all we are defining with the help of a constraint. So how we can disallow the null value? We can by specifying not null constraint as a part of a field definition. Field definition in what? At creating a table only, we'll define the field, right, with the help of their data types, right? So in that only we'll mention the constraints also. So if we are defining, like here for an example, I am defining my attribute S name, that is student name, as of a char data type, and I'm mentioning it as a not null. If I mention it not null, what it does? It won't accept any null value. So this is how we are disallowing null values. We are making a user not to enter any null value. In addition to this not null also, we can use a primary key, right? Primary key also won't allow any duplicate values as well as no null values, right? Okay. So not null is an implicit function of a primary key. You already know, right? Now let us see some of the example. Some example here mention it as to get the details of the student where the city is not null. select from the student means student is a table which is having a details of the students in which some columns is named with the city. So what I am saying here is if city is not null, then get the details. So try to see by implementing it. Okay. So this is your SQL workbench. I'm giving select asterisk from students. So okay, this is one of the table you can see on your screen, right? Which is having some student details like SID, name, city, and marks. All right. So in which I'm having some empty spaces also there and some null values is there. You can see on the 103 SID some null values there as well as 105 and 106 having some null values. So we'll implement some query on this. Okay. So what I'm saying, select all the details of student from the student table. Okay. Where city is not null, I am mentioning. So what I am saying, get the details of the student from the student table where city is not null. Okay, let us execute both so that you can understand. So these are the two tables. Okay, this one table. So first base table in which the city was null for 106. Okay, in the final query, that is second query, select asterisk from the student where city is not null. This is the output for that query, right? Okay, 13th table. So in that, no null values is going to be seen in the city column. You can see that. But for 101, I was having a space here. Means space mentioned but not mentioned as a null. So it is counting that, right? It is not no, it is also counting this and showing on the output. It is not neglecting this row, right? So by this you can confirm that the space is different and the null value is different, isn't it? If I'm saying the city is null, get the details of the students where city is null. What the output you'll get? Only the one column because null value is only one. So it's again not getting the first column. As I am having space also, it's not getting in the output. Only which I have given specifically as null, that is only getting as an output, right? This is how your null value is going to perform. Oh. Next, impact of null values on the SQL construct. Means what is the impact of this null value? We'll see. Boolean expressions arise in many contexts in SQL. The impact of null value must be recognized. Means how the null values is affecting each and every constraint or constructs of an SQL we are supposed to see. First, the presence of null value is in the definition of when two rows in a relation instance are regarded as a duplicate. Means what is going to say is, for if I am having a 4 columns and for the first row I am mentioning it as a null. Okay, I don't know the value, but simply I'm saying it as a null. For second column also null, third column also null, and for fourth column I'm defining some value. In the second row I'm doing the same, repeating same. For 3 columns I'm maintaining null and some value. So what the SQL think of these 2 rows as, it is thinks as of a duplicate because it's having a multiple null values now. So it will consider both as a duplicate. So redundancy problem is going to be occurs in this. So this is how the impact of null value is going to be affected. And the arithmetic operations, that is plus, minus, asterisk and division, returns a null value if one of their argument is null. Means if I am saying I am having one column with integer value, okay, and a second column also with integer value, and I want to apply a addition between those two values, and for one record I am maintaining the first column value is null and second value I am maintaining some 10 value. So when I am adding those two, what it will return? It will return directly as a null. It won't give any result there. So this is the impact of that null value on arithmetic operations also. Count. What that count does, what we are doing, we are for 6 members, like here, if I show you in the workbench, I'm having a record here, right? Maintaining records of student here. I'm maintaining here null. If I say count on city, so what it simply, it neglects the null value. It gives only 1, 2, 3, 4, 5 columns. So simply it's going to neglect. So that is how it's impact of count also. And with aggregate operations, yesterday in class we have seen now regarding. So if any single value is null value, the result value will also be a null. If we are using a count or something, that simply, the count discard. So these aggregate functions also discarding this null value, it won't count. So it's also affect our results. This is how with null values is impacting. Next, logical connectives and or and not. Okay, hope you have cleared with the null values. Next, go for the next concept, that is logical connectives, that is and or and not. What are those? Logical operators are those which returns true or false. The result has to be a true or false, that is a Boolean expression. So how they work, we'll see one by one. First, and the AND operator is used to compare the data with more than one condition. Means if we want to join more than one columns, okay, based on condition, that time we are going to use an AND operator. How? The syntax for that AND is selecting the columns from the table and giving the condition in where condition. So I am using these operators in where condition. You can see, for example, I have given select asterisk from the student where S name is Rahul and age is 20. So if it will give the result only when the name has to be Rahul and as well as age has to be 20. Let us see with one example here. We are having one more table here. I'll show to you. Okay. This is one table for students, okay, which is having some details, okay, as SID, S name, age, and city. So what the first example for AND we have taken there as select all the details from the students table, okay, where I have given the condition as where S name, your S name has to be Rahul as well as, and age has to be some 19, right? Okay, so which row is going to be selected now? Yeah, obviously second row is going to be displayed, right? So to filter the data based on the two condition or more than two condition, at that time we are going to use AND operator. AND operator, right? So I was comparing here S name as well as city na. So I have used an AND. Okay. Next, let's see. Next, that is OR operator. What it does, the OR operator displays a record if any of the conditions separated by or is true, means either first condition is true or second is condition is true, then the result will be true. But in the case of and, both has to be true, then only we'll get the result. So you can see here for a condition, sorry, syntax. Syntax is same as that of your AND operator. Okay. Now example, select asterisk from the student where your city has to be Hyderabad or Chennai. If it is either city is Chennai or, so what I am saying, your city has to be, city is very first one. Yeah, okay. Where city has to be Hyderabad, I'm saying, or city has to be Chennai. Okay, I'm executing this. What the output will get it as? I'll execute both the queries so that you can understand by comparison. Okay. So here on the base table, it was some up to 6 rows was there, including Bangalore city also. As we have given a query here with city, filtering along with city as a Chennai or Hyderabad, we are getting only 5 rows, right? Selected, right? Hyderabad and Chennai. The students who belong to, this is how you are going to filter. Next, not operator. What it does, it checks for the condition for not. If it is not there in that it is going to represent as a true. So what similar for that or, I'm saying that select asterisk from the student if not the countries have a country or city. Okay, the city is not Hyderabad, then displays the record. So you can see, just change here. Okay. Where cities Hyderabad, I'm saying. Okay. So only it's filtering Hyderabad now, and it's showing your rest of 4 details, right? This is how your logical operators are going to function. Yeah, okay. Hope you have understand. Next is complex integrity constraints. Okay. You have already seen some of the integrity constraints in your second unit. Right? What was the integrity constraints you have seen? Yes, like domain constraints, key constraints, right? So that has been defined over the columns, right? So that constraints are not enough to give a set of rules, right? In some way, there can be some case we were supposed to uh, give some set of rules or some conditions that so user cannot manipulate the data, right? Can do not change the table structure. So we are supposed to give in-depth rules. So to giving that in-depth rules, we are having some complex integrity constraints. So in that, whatever the topics we are having, let us see one by one. First one is constraints over a single table. There, in general integrity constraints, we were defining based on the columns. So first, let us see how we can define over a single table. So we can specify some complex constants over a single table by using some constants, right? So in that, we are defining a constants over a table with the help of check. Check is also one constant which is used to give some set of rules over a table. Okay. So for an example here, I am saying here, we need to check whether the enter ID number is greater than 0 or not for the employee table. right? Here, what I am doing, okay, I am creating a table for employee. And what I am doing, an employee had ID has to be a number, right? It should not be a null, right? And it should not be a zero. If I'm saying okay, it should not be a null. Simply by using a constant not null, I can give a column constraint check. Okay, means here for column I can define not null and I can make a user not to enter any null values. But how I can check for the zero? Well, yes, with the help of this complex integrity constant, that is here we are supposed to mention it as check whether employee ID is greater than zero or not. If it is not zero, don't allow the user to enter the value. Okay, so the above example, what it does, it creates a check constraints on the employee ID column and specify that it should only includes integers greater than zero. If it is zero, it's not going to accept, it's going to raise an error. So this is how your complex integrity constraints are defined over a table. Now, domain constraints. Okay, domain constraints. A user can define a domain by creating a separate domain statements also. Till now, we have we have created a table and whatever the constraints are there, right? We have used on the columns, right? We have not specifically defined any other conditions outer side of the table, right? Till now, we have not created any specific condition outside the table. Inside the table only, we were defining some constraints, right? Whatever it is, primary or not null. With the help of creation of table only, we were defining. But in SQL, it is possible to define some domain which is used for giving the conditions to the table separately. Okay, how we'll see now. So for that, we are having a check constraint, okay, which make a use of check constraint. Okay, it defines a condition. What do you mean by check first? It defines a condition for each row and it has to be satisfied, which means restrict value of column between the ranges. Means I am saying a user, if I am saying I am creating a table for a book, right? So obviously the user after reading a book gives some ratings, right? Online we'll have some feedback forms now. For that, if we want to create a table, in that column we will have a ratings. So ratings are given how? Between 1 to 10 they'll give now. Yes. So for that, we are supposed to restrict the user now. They can't give beyond the 10, they can't give less than 1. So we are supposed to define those range. Those range can be defined with the help of these checks. Okay, so how to create, how to define checks and how to do these domain constraints, we'll see with triggers. When I'm doing the triggers, I'll show you all this concept programmatically in SQL Workbench. Okay, till now just see what is domain constraint and see the syntax and examples here. Okay, so first how to create a domain. So if I am having a table of students with some attributes like roll number is there, name is there, mark is there. Okay, and my roll number should not be a zero, right? So for that, I need to define some constraints. So for that, what I'm doing, I'm creating a domain first. So for domain, we are supposed to give some names here with the help of a constraint. So what I'm doing first, creating a domain roll number. Okay, that is of type integer. I'm mentioning here. And for that constraint, I'm giving the name it as a roll test. Roll test. Okay, and I'm checking here with the help of check constraint that value has to be greater than zero, and that domain I'm using in my creation of table. Now you can see table creation. Create table student roll number app. Now this roll number is what? It is a domain now, right? Which we have created before. I'm utilizing this now here. And what is roll number? It defines that the value should not be a zero. It has to be greater than zero. That condition we are creating first as a domain here. Okay. This is how we are utilizing domain in creation of the table. Okay, we'll see once we'll do our triggers. Next are assertions. What do you mean by assertions? Assertions are also a constraints which are defined over a tables, not on only on a single table. We are defining this assertion on tables, more than one tables. Okay. Like constraints, we were defining the previous constraints which we have discussed in the unit 2 only column wise, right? And last we have to check the check constraints as a domain we have created. Next is assertions. Okay. So the general form to create an assertion is, as I can say syntax, that is create assertion, its name and check condition you are supposed to give. And you are in this condition you are supposed to maintain the ranges, value ranges. Means for what value you are maintaining a user to put that value inside that. Okay. An assertion must always be a true a transaction, and any modification that causes it to becomes false is rejected. Means if the condition is true only, then that assertion is going to be work. If any false, means that inside the query, if that condition is representing any false condition, that assertion is not going to be performed over those tables and you're going to get an error. So this assertion we can create as well as we can drop like a table. We were creating tables and we were deleting those tables with the help of a drop command. Similarly, we can create and we can drop the assertion also. So this is one of the example. What it's saying is create an assertion like a rich manager and checking a condition not exist. It has to be not exist in this. It should return false here. Then that assertion is going to be performed. What it's saying, select from the department and employee table where employee name is equal to department of manager name and the employee salary should not be should be less than 50,000. Means if the employee salary is less than 50,000, that employee is not going to be considered as a manager. So this assertion correctly guarantees that each manager makes more than 50,000. So by this assertion, we are saying that a manager salary has to be more than, and if someone is making a manager whose salary is less than 50,000, the insertion or objection is rejected. So with the help of this assertion, if I am using this assertion in some other tables, creating like, so I am making that user that it should not put the salary for manager less than 50,000. If it is putting that, it simply is going to be rejected. This is how your assertion is going to be performed. So in the today's class, we have discussed about the null values, right? And some logical operators and some complex integrity constraints. All right. Hope you have all got it. So I'll end this class for today. We'll see the next topic of triggers in the next lecture with the help of programmatic. Okay. That's all for today.